2.5 Equations of Lines and Linear Models. In the last section we talked about the slope formula, and if we have the independent variable x, the dependent variable y, and then for point x1, y1, the slope looks like this for this defined ordered pair, and then we have, for any value the independent, and then of course y depends on x. If you multiplied both sides by x minus x1, you would have m times the quantity x minus x1, which if we rewrote that to make it look a little more usual, y minus y1 equals m times the quantity x minus x1. We call that point slope form of a line, and if we were to add y1 to both sides, and then let's just say b, which is f of 0. So for any point x1, y1, after we solve for y, that negative m x1 plus y1, we're going to say that would be f of 0, because if you substituted 0 in for x, you'd have a 0 right here, so not x1, the independent variable x, and you would have y equals mx plus b, which looks a little cleaner than y equals negative mx1 plus y1, and this is called slope-intercept form. Standard form of a line is ax plus by equals c, where a is greater than 0, probably could have just wrote that a as a natural number. So ax plus by equals c, that's called standard form of a line. So let's say we have slope-intercept form of a line, y equals 7x plus 2. We would subtract 7x from both sides, and standard form by convention wants the coefficient of x to be a positive whole number, so that would be y equals 7x plus 2 written in standard form. Parallel lines have equal slopes, and for a perpendicular line to y equals mx plus b, the perpendicular slope is the negative reciprocal of the slope. So if the slope is m, you flip the fraction and multiply by -1, and then you have the perpendicular slope. So let's find m perpendicular. So our goal for the section is to be able to find equations of lines given various information about the lines. And no matter what information we start with, we need to get to where we know an ordered pair on the line and we know the slope. So each one of these examples, we're going to do some legwork to figure out a point and to figure out a slope and then go from there. So the various information we can be given. Let's write out what we can be given here. So the first one we'll talk about is if we're, actually let's not put it that way. Let's put it like this. What I was just writing would have meant that x1 is 0 and y1 is b, but let's put it like this. So the first one we're going to do is we're going to find an equation given the slope and the y-intercept. The next one would be given the slope and a point that is not the y-intercept. So if x1 is not 0, then y1 is not the y-intercept. The third would be given x1, y1, and x2, y2. And then the other types of problems that we can do are we can find a parallel line to a given line and then find a perpendicular line to a given line. So let's take a look at one of each of these. So that's probably my favorite one. If you need to find an equation given the slope and you know the y-intercept, you just use y equals mx plus b and plug in the value for m and b. So same instructions. Let's say that we are given the point 1, 4 is on the graph. And let's say m equals 6. We're going to use y minus y1 equals m times x minus x1. That's point slope form of a line. y1 is 4, m is 6, and x1 is 1. So if we were asked to give the answer in slope-intercept, the answer would be y equals 6x minus 2. If we were asked to give the answer in standard form, we would rearrange the equation such that we have ax plus by equals c, where the coefficient of x is a positive whole number, and so 6x minus y equals 2 would be standard form. let's say that we were given -2, 7, and how about 4, 10. Let's say we have these 2 points, and we need to find the equation of the line. So the first thing, if you go back a couple pages, is we always need a slope and a point. In this case, we have a point given to us, so we've already got that piece. We are not given the slope, so we need to find the slope. And we understand that slope is rate of change. We can do delta y over delta x. If you went back to the previous section, I put it on a graph and showed, okay, here's the change of y, change in y, change in x, all that. Now that we understand that and how rate of change works, just run it through the slope formula real quick. Be efficient. So y2 minus y1, as long as you don't get these ordered pairs mixed up. So if you pick 10 to be right here, then the x value from that ordered pair has to be right here also. You can switch these around, so you're going to end up with the same thing. It'll always, since the slope between any 2 points on a line is the same, it'll always reduce to 1/2. So for this line. So we have a slope of 1/2. Let's say that x1 equals -2, y1 equals 7, and m equals -1/2. Go to y minus y1 equals m times x minus x1. Let's plug in the values. So y minus 7 equals, I'm sorry, this is a positive 1/2. That's a positive 1/2. Keep track of positive and negative signs, which is something that all of us can get better at. So, this is going to be negative of -2 is +2 times 1/2, which is 1. Add 7 to both sides, so y equals 1/2 x plus 8. That's slope-intercept form. If you're asked to give the answer in slope-intercept form. And then standard form. Just said keep track of positives and negatives when we're doing all this. I'm going fast so that way I don't consume so much time on your video. Since this is a video, of course, you can pause. So I'm thinking fast, I'm writing fast, and I've made 2 errors on positives and negatives. Those things can get you. So this needs to be a minus y. From here to here, I multiplied by -1. Now, for standard form, I need to have a positive whole number out front. So I've got the positive taken care of. I need to multiply everything by 2. So x minus 2y equals -16 would be standard form of that line. Okay, so we're going to find the equation of the line parallel to 3x minus y equals 15 that passes through the point 2, 5. So we have a line given to us. We need to find the parallel slope. Then we need to give the equation of the line that is parallel to this line, and it must pass through 2, 5. So we need to find the parallel slope. That double backslash and the subscript is how I'm communicating parallel. So if we're going to find a parallel slope, we first need to find the original slope. So from 3x minus y equals 15, the most efficient way to do this, and I know if we hadn't already learned how rate of change works, we'd be finding 2 points, doing the rate of change between those 2 points. But we know how all of that works, so the most efficient thing to do here is take this line in standard form and put it in slope-intercept form. And if we were looking at a line in slope-intercept form, we know the coefficient of x is the slope. We could have started from here, found 2 ordered pairs on that line, done the rate of change, delta y over delta x, and we would have come up with m equals 3. Again, if I'm teaching that, I'm going to go the route where you find the change in y over the change in x, so that way you guys learn rate of change, all of that. We already know that. Our purpose is beyond just understanding rate of change in this problem, so the most efficient thing to do, rearrange to slope-intercept form, identify the coefficient of x. The coefficient of x is the slope. And remember that the slope is equal to the parallel slope, so the parallel slope is also 3. These lines will have the same slope but different y-intercepts. If they had the same slope and the same y-intercept, it would not be 2 different lines. So now let's find the equation. We got y minus y1 equals m, that's the parallel slope, which we know is the same as the original slope, x minus x1. If you didn't put the parallel little dashes there, that's definitely not a big deal. I'm just letting you know that we are going to the parallel line here. So there's x1, y1, y minus 5 equals 3 times x minus 2. So y minus 5 equals 3x minus 6. Y equals 3x minus 1. And if we are going to put this into standard form, the other thing about a parallel line in standard form is that we should have the same a and b. So standard form, the coefficient of x out here is a, and the coefficient of y is b. So capital A is 3 and capital B is -1 as the line that it's parallel to. So see, we've got 3x minus y here, and then equals 1 on this one, and then the other line, which these two are parallel, 3x minus y equals 15. So standard form can kind of help you check that. And then slope-intercept form, you would have y equals 3x because m is the same, and then just the y-intercept would be different. All right, let's find a perpendicular line. So to find the perpendicular slope, first we must find the slope of the original line, and it's in slope-intercept form, so we know that the original line has a slope of -1/5 given to us. If it were given to us in standard form, just like the previous example, rearrange it to slope-intercept form is the most efficient thing to do. Then you've got the slope. And then from the first part of this lecture, we showed that, or we wrote down that the perpendicular slope is the negative reciprocal of the slope. So all that means to you is if you know m is negative 1 over 5, flip the fraction and multiply by negative 1. The perpendicular slope is 5. Then we can do y minus y1 equals m times x minus x1 and in this case we actually had the y-intercept. We didn't even need to use point slope form. And there's the three different forms of the line. Just depends on whatever the question is asking for. We could have went straight to slope-intercept form since it gave us, this question gave us the y-intercept from the start. However, we don't always get the luxury of having the y-intercept, so point slope form always works. So it can't hurt to start there no matter what and get used to that.